Sampling procedures. So remember I said there's probability samples and non-probability samples. There are a lot of different probability samples. We've talked primarily in this course about simple random samples. In fact, that's all we're going to talk about in this course. If you take some electives, I've shoved other probability samples off into those electives. So we'll cover stratified samples in an elective and a little bit of cluster sampling as well. If you're interested, both Siegel and the marketing research book by Churchill and Yakabuchi talk about especially stratified samples. Churchill and Yakabuchi also talk about cluster samples. We don't have time to really get into that here, but you can read about it in Siegel if you want. Now let's talk a little bit more about the non-sampling errors, which I've called biases back here. So, a lot of these I've already introduced in my example, but let's just give a little more comprehensive treatment to this. So, within non-sampling errors, so this is the difference between the mean of the statistic, so it's and the parameter. So the B in my formula are bias. These can come about through respondent errors and administrative errors, in addition to the sampling frame bias that we talked about earlier. So within respondent errors, you have the self-selection bias. So if I choose not to participate, that's going to create a bias. Sometimes you'll get other issues where you get respondents who don't like you and they want to make your life miserable by giving you garbage information. So the technical term for this is deliberate falsification. So we've seen examples of this on the CPK survey where somebody gave you garbage data and told you that they went to 99 casual dining restaurants in the past 30 days, which would be kind of hard to do. It's an example of deliberate falsification, probably, where that respondent just didn't like taking that survey and decided to give you rubbish data. Often you get rubbish data and the respondent didn't mean to give you rubbish data. So this is unconscious misrepresentation. I'll give you a quick example of this. I did a survey of newspaper readers, and I asked, over the past 30 days, how many times have you read or looked into a Sunday newspaper? Now, when I ran a frequency distribution of the responses, what I found was that there was a whole lot of people who would not look at it at all, quite a few number of people who looked at a Sunday newspaper 4 times or maybe 5, 6, 7 times. But then there was also a big clump of people who looked at it 30 or 31 times. And I couldn't believe this. I couldn't believe that someone's going to keep that Sunday newspaper around and look at it 30 times in the month. What probably happened was that the respondent didn't see the word Sunday newspaper and just answered the question, how many times have you read or looked into a newspaper in the past month? So in that case, it's really hard to make use of that question. You're not quite sure what question the person was really answering, so we ended up having to ditch that question. There's also lots of examples of how biases can creep in because of administrative errors. So sometimes these can come in very subtle ways. So whenever you have an interviewer asking the question, so you have someone intercepting someone in third world countries, often you have to do one-on-one interviews because you don't have the infrastructure to do internet or phone surveys. You may be dealing with a lot of illiterates where you have to have people out in the field. So whenever you have interviewers, beware. You need to train those interviewers very, very well, because an interviewer can bias the response and not even know it. So if you have somebody who's very very charming and very enthusiastic, you're going to get different responses than if you have somebody who's very grumpy. Sometimes you'll get cheating from an interviewer. One of my favorite examples of this is a personal example. So when I was, I'm going to say I was 32 years old, I was at a mall one day, and an interviewer walked up to me and said, "Excuse me, sir, do you have time to take a survey?" And I said, "Sure." The first question that the interviewer asked me was, "What is your age?" And so I said, "I'm 32 years old." And with that, the interviewer said, "Well, could you say you're 29?" And I said, "Okay, fine, I'm 29. So what's going on there? That first question was probably a screening question. The target population was, had an upper limit of 29. I was a warm body that was willing to talk to this guy, and he wasn't going to let me go just because I was a couple of years over the limit. Okay, so there's one example of cheating. This person took me into the back room of one of the side rooms and sat me down and asked me to watch some movie trailers. Okay, so I watched this movie trailer, and then he asked me a question like, "What did you find most scary about this movie trailer?" And I said, "Well, I didn't find anything scary about it. I thought it was pretty stupid." And then with that, the interviewer said, "Well, just say the knife. That's what everybody else is saying." Okay, so there's another example of cheating where the interviewer is just putting words into my mouth. Now think about what's going on here. Some movie company or advertising agency is paying good money, probably 30, 50 bucks from my complete, to get data that's absolute rubbish. So first off, I'm not in the population. Secondly, they're not getting my answers. They're getting whatever this interviewer thinks I ought to be saying. All right, so that's an example of cheating. The remedy for this is for you to negotiate with your market research vendor for things like adequate supervision of the interviewers. So the proper way to deal with this is get my phone number and have that interviewer record my phone number and then call me up later and ask me whether this was a legitimate interview. And so was I led or whatever? So you have to do a follow-up survey of those interviewed to make sure that there wasn't just cheating. I'll give you another example of cheating. I was walking around downtown one day, and someone came up with a clipboard and said, "Excuse me, sir, do you have time to take a survey?" I said, "Sure," and the person asked me a couple questions, including my phone number, and then said, "Listen, if my supervisor calls you up tonight, tell him this interview took 45 minutes. So what's going on there? What's going to happen is that interviewer is going to go home and fill out probably a very long questionnaire, and then claim credit for this, but it's a whole lot easier for that interviewer to fill out the questionnaire than for that interviewer to ask me all the questions and get my responses. So they can probably get a whole lot more completes. They're probably being compensated on the number of completes." Turned out that evening I did get a call. The supervisor said, "How long did the interview it took?" And I said it took 1 minute. And she said, "Thank you very much." She knew that the data that they'd claimed to have gotten from me was rubbish. So these are all things that you got to think about while you're negotiating with your market research vendor. Administrative errors, it can be coding errors and so forth. All right, let's talk a little bit about non-probability samples. There's two types of, don't get too concerned about whether something is a convenience sample or judgment sample, or other books will talk about other flavors of non-probability samples. Just realize that these things are biased. So convenience samples are those where subjects just enter by accident. Judgment is where the interviewer thinks this person would be, very representative, therefore I'm going to interview that person. These both create biases. So let's talk a little bit about convenience samples. My favorite simple example of something like this would be if I wanted to survey all Northwestern University students, so that's my population, and I decide to walk over to the College Center at lunch, and I intercept 20 people standing around the College Center. Okay, so that would be a great example of a convenient sample. So those who entered the survey enter simply by accident. They happen to be at the College Center at lunch, and they had a little bit of time to talk to me. So that's a very lousy sample. So think about who's excluded. People who never go to the College Center. So all of the distance students in the IMC program never go to the College Center. All of the part-time students rarely go to the College Center. If you're an engineering student, you're up on the other end of campus. If you're a medical student, well, you're downtown. You never go to the College Center. So all of those students are systematically excluded from my survey, and that would be very poor. What would be better is to get a roster of all students enrolled at Northwestern and do some sort of email survey. Okay, now, big lesson, big message here. This sounds obvious, but students often have a hard time grasping this. Large biased samples are still biased. So let's think about what happens when you have a large biased sample. So let's go back to the picture that I showed you before. If you have a bias, you're not estimating mu, you're estimating mu plus b. Now, what happens if you have a bigger sample that's biased? Well, okay, we know, go back to this previous slide here, we know that the standard deviation of the sampling distribution is sigma over root n, right? So what's going to happen when n gets bigger? Well, here's what's going to happen. If you go from a sample of 1,000, you're going to have quite a bit of variation around the mean of this distribution, mu plus b. If we go from an n of 1,000 to 4,000, well, okay, you're sticking 4,000 in the denominator rather than 1,000, and your statistic on average is going to be a whole lot closer to mu plus b, but you're a whole lot closer to mu plus b rather than to mu. So, the point here is, when you have a biased procedure, whether it's through a leading question or a sampling frame bias or non-response biases, having a big sample is not really that much of a help. Sherry Height had 4,500, but it was biased. So what? Right? It's not very good. All right, it's just repeating the same basic mistake. Here's the mistake. That B is the mistake. You're estimating the wrong thing much more reliably. So larger samples give you a more precise measure of the wrong thing. So very often you have the choice between lots of bad data, or you can spend your money getting a small sample that's good. You're much better off with a small sample that is not biased or not as biased than just gathering loads of biased data. Let me give you a classic example. It's covered in most statistics books of this point. It's not unlike the Sherry Height example. This probably was one of the largest mistakes ever. So in 1936, there was a presidential election between President Franklin Delano Roosevelt, and his challenger was Alfred Landon. Now, at the time, people kind of thought that Roosevelt was going to sweep, but the premier polling organization at that time was a magazine called the Literary Digest. So it was a magazine that had correctly predicted every election since 1916 they did their survey and they came out with the prediction that Landon was going to win in a landslide, 57% to 43%. Now that really is a landslide. The elections today are decided by much smaller percentages than that. It turned out the actual result was that Roosevelt won in a huge landslide. 62% of the people voted for Roosevelt. So the poll guessed 43% for Roosevelt. Roosevelt, in fact, got 62%. So the poll was off by 19%. So what happened? So the Literary Digest prediction was based on a very impressive sample, 2.4 million. Today we don't see samples of 2.4 million people forecasting election results. They're usually based on hundreds or maybe thousands in a more impressive case. So there's a big difference between a couple thousand and 2.4 million. So this is a mammoth sample even by today's standards. But again, the sample size doesn't matter. What matters is how you gathered the data. So, what are the usual questions? Well, the usual questions are what was the response rate? Response rate was 24%. Literary Digest sent out 10 million postcards to get the 2.4, which is a 24% response rate. So, people who responded were systematically different. Other question you should always ask is, where'd you get your names? In the case of Literary Digest, they got their names from telephone books. Well, today that might not seem like such a bad idea, but in 1936 it was a horrible idea because who had phones in 1936? It was only the wealthier people who tended to vote for Landon. So only 25% of the households at that time had phones. Club membership lists like Rotary. Well, who belongs to Rotary? Usually your more established, affluent citizens. Automobile registration lists. Again, who owned an automobile in 1936? So it's almost mind-boggling that this magazine would make such simple mistakes, but they did. So again, the moral of the story is that non-respondents can be very different from respondents. When you have biased samples, watch out. Big samples don't help you. If you have a high non-response rate, look out for non-response bias. This particular survey has been analyzed in great detail in a lot of places. People did further analyses on Allentown, Pennsylvania. Allentown, Pennsylvania is interesting because Literary Digest had a perfect sampling frame from Allentown, Pennsylvania. So they could mail every registered voter out, a survey. The problem was their estimates in Allentown, Pennsylvania were still way off. Why? Because of the non-response rate. So some of the people who received this card opted out, and those who opted out tended to be Roosevelt supporters. So beware. Okay, that's it for this this lecture. We're going to do this Can the Survey Be Saved case either as a case discussion in class or as a board discussion board question for the distance learners.